Okay, the second type fits this domain restriction. We're trying to divide by a value of x in the denominator. Anytime you do that, you have to state that whatever's in the denominator cannot equal 0, just like we did in this second example here. The denominator cannot equal 0 because you can't divide by 0, so both of those values cannot equal 0. Now there's two different types that we're going to learn. One is a linear type and one's a quadratic type. The linear type is very easy. You just say x plus 6 cannot equal 0 because there's no radical, so we have no inequality symbol, but we do have a denominator with x in it, and we can't divide by x. Now you just solve this. X cannot be negative 6. On a number line, this would look like so. Okay, there's my open circle, meaning that negative 6 is not included in my solution set. And I'm going to show it on both sides because it can be everything else. This is saying all real numbers except for negative 6. Any other answer is fair game. And the way you write this in interval notation is you have negative infinity to negative 6 and negative 6 to infinity. That would be interval notation. On a graph, there would be a vertical asymptote at that value. For quadratic types, okay, we were just started off the same way. X squared plus 5x minus 24 cannot equal 0. Okay, this is a quadratic, and you have to solve that any way that you possibly can. Factoring is always the easiest, so try to factor it. And this one factors as x plus 8 times x minus 3. And we use the zero product property, and we say x plus 8 cannot equal 0, and x minus 3 cannot equal 0. So we set each factor equal to 0. And now these are both linear types, so we say x cannot equal negative 8, and x cannot equal negative 3. So on our number line, we have negative 8 on the left, negative 3, but it can be any other value except for those. So we're going to shade every direction to the right and the left and the middle. Okay, and the way you write this in interval notation is you say, well, it can go from negative infinity to negative 8, but it can't be negative 8. So that's how you exclude negative 8 using interval notation. And then it can go to negative 3, but it can't be negative 3.